Okay, welcome everyone to today's KVA here, hosted by KETIV, and we have an amazing guest with us today, Ted Ward. But I'm going to give you a few minutes to get comfortable. We have a number of people who are arriving for the webinar in the KVA series, and so we will give you a minute or two to refresh your coffee, sharpen your flat end mill, and finish up that last little bit of a tool path. Maybe using a pencil
trace
somewhere in the corner. Finish that up. All right, let's go ahead and get started. And again, welcome everyone to our KVA series here at KETIV. Hopefully that you are all enjoying these series. It's very popular with our customers, and it's our pleasure to be able to provide these on a weekly basis with lots of information. And so today we will be discussing the new release highlights of Fusion 360 with PowerMill. And we have a very special guest with us, Mr. Ted Ward, who is probably the leading technical expert on PowerMill in North America. So it's
kind words.
It's out there. I'm going to put it out there, but I'm super happy to have you, Ted. So if you're going to introduce yourself for a moment, that'd be great.
Thank you. Hello, everyone. Yes, my name's Ted, solutions engineer for Autodesk. Currently living in Windsor, Ontario, Canada, but moved over from the UK back in 2002.
And Ted, you date back to the Delcam days, right?
I do, yes. I joined Delcam in Birmingham, UK back in 1999.
Yeah, so a long history with the development of these products, and we are, again, just super pumped to have you here to share your knowledge. So let me just give you a quick update on some future events, and I'm going to turn it over to Ted. All right, so as you can see, you can hit the QR code, give you lots of information about upcoming events. But next week, June 15th, we have the simulation drivers increasing value in our mid-medical technical industry. And then on June 22nd, we have another one of these in a series of what's new in Fusion 360. And so we'll get more into the product line and the platform of Fusion 360, which is always exciting. And so if you need support, there's a number here for you to jot down. You can always visit kva.com or ketiv.com/kva, or just click on the QR code for a lot of back history and data. So with that, thank you. And I'm Joe Bailey. I am new to KETIV, been here a year, and I am running the sales organization on the Autodesk side. But Ted, all yours.
Thank you, Joe. Hello, everyone. Yes, just to repeat myself. Yep, Ted, solutions engineer for Autodesk. Before we get into today's presentation, just have to highlight the safe harbor statement, which basically covers me for anything I might say regarding any kind of future developments and things like that. But I'll warn you if anything like that sort of comes up, but we'll just put that up quickly anyway. So the agenda then, so this is the release of PowerMill 2024. We're going to be going through, again, not all of the enhancements and updates, but we've really just sort of cherry picked 6 for today's webinar. Going over the what's new, and then at the end we'll have a few slides on how you can learn more, where you can get PowerMill from, etc., and a few other little bits of information for you. Yeah, so like I said, this is version 2024. The release date there, obviously that's been and passed, so everyone's able to download that or the updated version or they may have already, I don't know. But today, the release theme is not so much large things. It's more about like the speed and the quality and reliability, and just the things that would make your programming of any type of job quicker and easier, and again more reliable for you. So aiding in things like automation and less work for you as a user there. But let's go through those 6 highlights that I just mentioned. But first of all, we are going to start off with a brand new, not so much brand new, but a different type of calculation of the Flowline toolpath. Now, in particular, this was quite a cumbersome toolpath to make, just because of the way and what you had to do to set up. It would require you to have, go through and really like sort of create fiddly sort of patterns, and you could get some good results and maybe some sort of inconsistent results. So the new calculation gives us a far smoother, and a far easier toolpath to set up. Then some additional updates for the flat machining toolpath. Now, today we're going to be focusing on in particular, the inclined flats example. This was released in a previous version, which allows us to fully program flats in a 3+2 sort of 5-axis scenario, if you possess obviously the equipment to do that. But some nice filtering tools there. Again, this is just going to save you time after you've created the toolpath, and save you having to sort of go in and do any sort of fine adjustments. So that's a flat area filter. Axial engagement. Now, we'll go through some examples, and again, I'm just going to talk about them first of all. Then we're going to go into the actual software, and I'll just highlight, where these new features and functions are. But this one, minimum axial engagement. Now, if you're looking at the, any kind of sort of trachoidal or adaptive style roughing technique, you're really going into, deep depths of cut, and this is just going to allow you to filter out any nasty sort of fragment moves that could be detrimental to the tool. But again, we'll look at that in more detail. The rest finishing toolpath now has the addition of an overlap, which is good. Obviously, we want to blend these toolpaths, nice and smooth in those sort of intricate corners. So that's going to allow us to safely do that. And then there's some enhancements to the setups, building on the previous work that's happened, where we can define, a list of parameters up ahead of time. And now we've just added the addition of the point distribution form there. So again, we're just adding more and more parameters. That's just going to make our programming, cleaner and easier for the user there. And then some safety features really for the deep drilling. Just a couple of additional parameters where it is going to potentially stop any kind of accidents happening on the machine and your part itself, just by allowing us to keep that tool, if we're doing, for example here, a deep drilling cycle, keep the tool within the hole, and it's just going to prevent any kind of mishaps at the machine. So that's a good one. Yeah, so okay, so highlighting each one here, the Flowline finishing toolpath. Now, we've had that before, but we still have it actually, but there's been an addition of a new type of calculation where, again, I mentioned earlier, you don't have to really go through the the process, or the fiddly process of creating your what's called an embedded pattern. You'd have to create one kind of pattern, then you'd have to be do a little bit of editing to give yourself like 4 curves, maybe a top curve and a bottom curve, and the results weren't always as as intended, I suppose. So you could get some good and some bad results, and depending on the type of part, and if the part had any kind of gaps, for example, that toolpath wouldn't then be looking good. But this one is going to give us a far better toolpath, and the impact, as it says there, leading to faster CAD programming, better toolpath quality, and obviously better surface finish. So that's a nice one. The let's just go back. I lent on the keyboard there. Yes, the enhanced flat machining. Now, obviously we've got flat toolpaths in various different forms here, but one that's been added in the previous release was the inclined flats. Now, obviously we'll go into it in detail and show you the actual toolpath, but if you look at the picture on the right there, you can see those blue ribs where normally that kind of feature we would be looking to finish that in a completely sort of different way, maybe. So we may not want that flat toolpath calculation over those, sort of intricate detail areas. So instead of us editing afterwards, obviously it's easy to do, but again, it's extra steps. So this kind of feature and functionality will allow us to do more automation. Yeah, so that's going to obviously appear, or you'll see that in the other flat machining strategies, but we're going to go into that in more detail. But again, shorter CAM programming times, no need or less need for manual intervention, which PowerMill's good at, as we know. The editing is second to none, but the less we can do, the better, right? Rest finish and overlap. That's, if you look at the other corner finishing toolpaths, we have that overlap factor. We had, let me try and think of these, multi-pencil, we had corner pencil, we had corner finishing. They all were good in certain scenarios, but not, you'd have to probably explore, the different types of toolpath depending on the type of job there. So rest finishing was brought in really to sort of encompass all of the good bits of those toolpaths and allow it to be multi-axis at the same time, but it never had that overlap, and that's the important bit where we're blending between, let's say, the steep and the shallow areas of your previous toolpath. So that overlap is important, so we don't leave those, the blend marks there. And again, that's going to, again, it says there, improve the quality of the machine parts, and the most important thing is remove the need for that manual finishing at the end, so we can get it off the machine, for example, and save time on the manual finishing or the polishing aspect. Now, the minimum axial engagement, you'll find this in any kind of roughing toolpath that uses that, that's enabling you to use the step cutting. Now, really, this would be, your traditional style roughing toolpaths are, a wide step over, shallow depth of cut. Now, the more sort of high speed methods used today, I suppose, and again, it depends on the scenario, but they would normally be, a solid carbide, deep depth of cut, and then a small step over. And so obviously with a deep depth of cut, we would be leaving those, the terrace effect or the steps. So that, you'd introduce your step cutting, but the problem with that was you could end up with these small sort of sliver cuts that would really be detrimental to the tool. You could end up, first of all, it's going to be machining far longer than it needs to be. Plus, you run the risk of, of having to change your tool a bit more. It will do damage to the tips, etc., or the edges of that tool. So that's a good one, and that's going to be it's a filter where we can define, make sure my smallest depth of cut is at the number that I specify. So that's going to obviously improve efficiency, leading to shorter cycle times, and like I just mentioned there, the improvement of the cutting tool life. And as we know, tools are expensive, and someone didn't turn their phone off, so my apologies. I'll do that right now. Bear with me. My apologies, Joe.
It could be one of our participants calling you.
I know. It's probably one of my colleagues playing a trick. Anyway, okay, that's off. Okay, my apologies. Moving on. Okay, so building on the improvements to setups. Now, setups is really like, I've always in the past, I suppose, when I'm programming, I'm really trying to do manual organizing of toolpaths myself, where, I'll be creating folders and doing that kind of organizing. And although you can do that, setups were introduced where, you could apply really the key here is global settings. So I can just define a stock, the machine, the attachment to the machine, clamps, any sort of necessary leads and links, but apply them once in the setup, and then every toolpath you're subsequently making after that is going to be, following those global settings. So this is, I mean, what they've done now is really just added the addition of the point spacing, where as well as all of the, the previous bits and pieces that I just mentioned, you can set up now, for a machine that, some machines love points, some machines love arcs. So we can really just predefine all of these parameters ahead of time. And again, it just makes for better organization. And I think one of the key points as well there is, let's just say I want to modify some of those settings afterwards. Now, if you've got 20 toolpaths, you would have to probably go and either have some kind of, call it a high-end macro that's going to do that work for you, or just be a lot of sort of manual, user input there. So the setups allow us to really, apply those maybe adjustments after the fact, so making multiple, for example, again, the point spacing for a particular machine, you may want to run your particular toolpaths on a different machine. So we need to rapidly make those updates so we can carry on, programming. Or even something I could show a little bit later, maybe just adjust the leads and links, but instead of applying them to one toolpath, you can apply them to multiple toolpaths. Safer deep drilling, yeah. So with the traditional, let's call it like a deep hole sort of pecking cycle. Now, depending on the depth of the hole, there was a bit of a safety issue with previous methods, and you didn't have this functionality where you could control, whether you wanted the tool on its pecking cycle, for example, to come out of the hole fully or even stay in the hole. Now, anyone that's done this kind of work with deep drills knows that they are not always running true, or they're wobbly, basically. So we're in the machine, they could be running out, not a problem for once they're in the hole, but the initial engagement of the hole could be an issue where the tool could catch on some swarf, or basically the long and short of it is it could end up damaging your job. So now there's some additional functionality to allow us to either define a positive number, which would just have it sort of outside of the top of the hole, or even a negative number where it will keep the tool within the hole. So if it's within the hole, then it's going to reduce any kind of problems leading to tool breakages there. And even more than that, over the tool, avoid damaging the model, or the tool that you've been working on, the workpiece that's you could have 20 to 100 hours already programmed in it. So that's a nice safety feature for drilling there. So yeah, the graphic there, I'll just quickly go through this, but distance from top. Now again, we couldn't really control this effectively before, but now on the right hand side, you've got the one on the left is coming out with a positive number. The one on the right there is a negative number. So again, it's keeping it within the hole, so less likelihood of anything going awry with something that's going to hinder that tool entering the hole properly. Now also for that clearance, the clearance values as well, I think originally we had what's called like the retract factor, which was like a percentage. So effectively what that led to was really like a decrease in, obviously with a deep hole drilling cycle, you're really going to be decreasing that peck as you get towards the bottom, right? Because it's not as sturdy, or you're deep into that hole, so you would like to decrease your peck. But with that retract factor, it would then really decrease that the clearance value as well. So that clearance, that as it does that pecking cycle, would not sometimes be able to clear the swarf that's invariably going to be at the bottom of the hole. So it was decreasing every time. Whereas now the retract length, it's going to be just a specific number that you want to have. So even though the peck is going to be decreasing in depth, that clearance value stays consistent. much better scenario. So I haven't really got a project for this automatic raster angle, but I can show this when I get into the inclined flats portion of, you know, when I go into the actual software, which I'll be doing shortly. You know, we'll just go and show you again where all these buttons and features are stored and placed. But the raster angle there, yeah, I mean, with any kind of raster toolbar, or sorry, flat toolbar, for example, you know, you can have a fixed raster angle. You can look at the job and say, right, I want to machine along X, or I want to go 45 degrees or even along Y. Or you could, you know, if you don't have that time and we're looking to automate our toolpaths a bit more, you can let PowerMill decide automatically. So it didn't always get it right. It was good, but it wasn't as good as it could be. So they've made it a bit more inconsistent with that raster angle, you know, improving, giving you more efficient toolpaths, as it says there. Greater programming consistency, but the big one is, you know, if you don't touch the toolpath, it's better automation, isn't it? The less we touch, you know, the better, really. But I'll show that when I do the inclined flats afterwards. But quickly summarize, there's the 6 points that I've waffled on about a bit too much, I suppose. But let's get into the software and a bit of technical now, and we'll show you the good bits and you know, where we go about finding these features and functions. Right, so I'll quickly switch over. There we go. Okay, so to help me, to aid me with the projects that I've got here, we're going to be using something you may have seen already, but this is what we call our rolling demo. Now, it's a really useful tool for learning, for showing people, teaching. It's just a good way of storing your projects and something you can use, you know, for multiple different reasons there. But if I just click on the picture there, it should hopefully load my Flowline project. Now, just to keep an eye on time here. Okay, yeah, so we've got a part set up on, you know, on a fixture. I'm not going to show any kind of machine, but I've got the fixture and some tabs, and there's the part that we can see there. Now, this kind of component part, now, really there was no specific kind of you know, or should I say, the way of finishing this fillet. Normally you would, you know, some kind of steep finishing toolpath, some kind of shallow finishing toolpath, and then the fillets are always, what I've done in the past, the last bit to blend. Now we could do some kind of corner finishing, but that's really for internal corners, not external. So for this kind of toolpath, we would look at, you know, we've had that Flowline toolpath in the past, but what I'd have to do is go through that mundane process, fiddly process on a part that could be less than perfect. And you know, we all, you know, we come across parts that are good. Some are, some have gaps, some don't. Right? Obviously, we're dealing with parts from various different people and customers, so it would not lead to very sort of consistent results. Now, if we open up that form, let's have a quick look. Now, this was, I'll just create a quick copy here. Look, so the two options there are on surface. That would be the old style calculation, and that would require me to make an embedded pattern. And again, that would be a fiddly process. I'd have to order it correctly, and then have some kind of top curve, some kind of bottom curve, and then an intermediate curve or two, but that would have to be embedded. Now, embedded would be an extra process where we gain information from you know, the underlying model. So sometimes that would be a time-consuming process. Now, if we go to tooltip, which is the new option, we still have to define curves, a quick top curve and a bottom curve, but they don't have to be embedded. They don't have to, but they suffer less and are far quicker to produce. Now, again, as we know, we've got several different ways of creating those patterns, but if we were to look at one that was created with the on-surface kind of style, now what you'd find a lot of the time is we would have, I'll just highlight some areas, let's get the right rotation right, but we'd have sort of inconsistent, we'd have breaks in the toolpath. Now, I've got a grey background here. I could switch, but hopefully you can see that. But we might have some weird kind of gaps, and that could be from a gap in the actual surface of the model, for example, or we could have scenarios where it doesn't really just doesn't do exactly what we want it to do, and it suffered from that. You could get some good results, and then it was just inconsistent. Now, if you look at the same toolpath, now what I haven't shown here is sometimes I will create some fill-in sort of areas of the model. Now, we could do this at the design stage, or we could go ahead and quickly create some fill-in surfaces ourselves, which are quite easy to do. But if you think about, if I didn't have those fill-in surfaces there, the toolpath might, it's going to follow the edge of the gold surface there and really not be, it could be okay in some scenarios, but if you want to go ahead and add some fill-in surfaces, you could, and it would give a far smoother result. So talking about that, if we go to the tooltip option, no breaks at all. We're getting a far more consistent toolpath, meaning less work for me as a user, less fiddling as well, creating those the patterns ahead of time. But I think the big thing here is, even if I got a good toolpath with the previous version, it did not have the ability to do a spiral kind of toolpath, right? So basically one in, or one sort of lead in and one lead out. Now, even though I've got a nice toolpath there, I've got multiple smooth leads and links, but as you probably know, the tool is always going to be deflecting at some point. So anytime that we can keep the tool on the material, it will suffer from less marks that we may have to go and finish afterwards. So if we go on one stage from that, we can turn the spiral on, and then we've just got the one consistent sort of lead in, lead out. And again, that's going to be maximizing our finish, and again, consistency, and and obviously decreasing the amount of time that I have to create that toolpath. Okay, let's move on to the next one. I think this is the drilling, and we'll quickly go on to the drilling here. Now, we saw this in the deck there, but again, I'll just show exactly where it is in the form there, but let's load the project. I'll turn off my rolling demo, and we'll activate, actually, we'll calculate these two. This one is the positive value. Let's quickly go ahead and look at the form, the retraction. You've got this distance from top being positive, and then we'll go ahead and do the distance from top being negative, and that's the one that's we're going to be controlling and staying within the hole, a much safer scenario. Okay, let's activate that positive value toolpath. So simulate from start. Quickly turn the tool on as well so we can see. Right, let's shade that model as well. So we've got we can see into the model, we've got it shaded, but let's simulate, and we should see that come in. And again, not the scenario I want here, but now obviously we can do either, whatever's going to suit. Oops, did that a bit quick. So again, always coming out of the hole. Now that tool again is they never really run in that kind of, they're bent, basically, they wobble. They always suffer from that kind of wobble. So any kind of media that's on the top of the part there could cause that tool to really jam into the job, and again snap your tool, potentially hurt your machine, and even more importantly, a customer's job. So having it stay within that hole leads to a far better scenario. So here's the negative, and you can see it now just staying on a user-defined value within that hole, something that we couldn't do before. So a great addition to 2024. And then we'll quickly highlight this PEC reduction. We'll turn the model off for that, I think. Let's look at PEC reduction. That was 2023, and I think what we'll see there is it's gradually getting smaller and smaller. The PEC's getting smaller, but because we're using that retract factor, the clearance would be getting smaller and smaller every time, but that swath is going to stay the same size. So we want that number to be consistent, right? We work out that clearance value that we want, and then we're going to get more consistent spacing on that particular toolpath or that drilling toolpath. So a couple of good safety revisions for the drilling in 2024. Right, flat finishing. So as I mentioned earlier, while we load that project, there are a multitude, well, there's a few different ways of creating flat style toolpaths in PowerMill. In the previous release though, you had the addition of what's called inclined flats. Now, if you think about, let's just minimize this. If you think about machining the flats on a part that was, well, has multi angles, right? And if you've got the ability to do that on a 5-axis machine, the previous method would require you to really go ahead and again have some kind of in-depth, complicated macro that that you could use, but not everyone could or would do that. So you would end up having multiple toolpaths, multiple flat toolpaths, one for each. Think of a cube, one for every face of that cube, for example, and then go ahead and attach them all or join them all in an NC program. But again, multiple toolpaths. Now, with the inclined flats, it allows me to define a start range and an end range of angles on your machine. So really, I'll show that last, but it allows us to, if you needed to, we could machine, that flat there, the side of the part. Now this would probably squared up beforehand, but you may have flats within the part, multiple flat areas where, obviously some are reachable and some are not. So that's down to PowerMill to decide, and whether it can get into those areas. But these ones here, I could machine that if it's flat, of course, with a flat profiled tool. So you could really just go ahead and set PowerMill off, and it will find out all of those flat areas and produce some kind of 3+2 5-axis toolpath. But again, this addition has really just given us a bit more control of that aspect of it's a filtering tool. So a lot of other toolpaths have filtering for fragment bits of toolpath, but this is just allowing us to really keep it away from, and in this case, a small detailed area. Now, we also talked about the automatic raster angle, so I thought that I would just show that within the inclined flats portion as well while we're here, and I'll get to the other stuff in a few minutes there. But if we activate that fixed angle, let's look at the settings in the particular toolpath. Now, the good thing about this is, now the other toolpaths are offset flat finishing or raster flat finishing. This one, I'm able to choose or have a choice of 3 different styles. And again, not every part is going to be the same. Not everyone thinks the same. So it just gives them the ability to pick and choose from within that same form instead of having to open up another style, for example. But let's create that the raster one at a fixed angle, and again you can just put in the number there, but let's go ahead and calculate. Okay, so we've just picked just a manual angle of, say, I think it was 0 degrees, wasn't it? I could easily check that by rotating. So 0's normally at 3 o'clock in the CAD world. So yeah, so we've defined that angle, but it may not necessarily be, it might not be good for all areas of the model. So in that case, we could go ahead and let PowerMill decide, and that's where they've done the improvements. The auto angle, so all we do here is just untick fixed direction and let PowerMill decide. So what it's going to do is really evaluate the length or the width of all of these flat areas, and then decide from that what direction it should take. So what you'll see is some areas where it's going along, let's say along the x-axis, along the y-axis, and things like that. So there's just been some improvements, to really reduce the amount of on machine time or the toolpath, not the calculation time. Obviously, that always goes on, but in the amount of time it would take to cut that particular style of toolpath on the machine. So it's just again far more consistent, far better, and then shorter programming times there. Now, from that same toolpath, we could also go ahead and switch the type of style. Now, again, this isn't necessarily new to 2024, but I think it's always good to show bits from the past, right? Then leading into some of the new stuff. So we just use the raster variety there, or the type of toolpath. Now, this one is offset model. Sure, we all understand the offset style strategy, but again, the filtering tool that we're getting to is available for all of these particular styles and the types we're going to be looking at here. So this is the offset strategy. Again, you can see the difference. And then obviously the bit that we're really interested in is the use of the filtering. So if we go to the flat tab, let's open up the next one, have the filtering turned on. So this is the new bit here. And really just filtering out areas that we don't want it to go ahead and touch. Now, that area of detail is something probably that, yes, we want to stay away from. We don't really want to have any kind of potential for tool marks in an area, so we may want to just approach it in a different fashion. So we turn on this filtering tool, and again, that's a user-defined number, but the outcome of that is that hopefully it should be staying away from the areas that we don't want it to touch. It's going to go shortly. Or maybe not. Oh dear. Oh, there we go. Oof. Had me going for a second there. Oh well, we got there for some reason, so I'm not too sure. Hopefully my kid's not on his Nintendo Switch at the back there, but you never know. Right, so that has basically done exactly what we need to do. Filtered out those areas nicely, and again we would come in with some kind of approach more appropriate. And then I won't go into the offset at all, but again that's another different type of offset shape of toolpath, and again you can really just choose all of them from that particular form. But I mentioned the 3+2. Now if we go into the particular toolpath, now that normally would take 4 different toolpaths to fully machine the outside, for example. Or again, all this is if we just quickly recycle that toolpath, you've got the flats tab there, and this is really where we can decide what kind of sort of angular limits you'd match these to your machine, obviously, whether we can or whether we can't get to them. But a start angle of 0 degrees, 0 degrees being the sides basically, up to a user-defined number. But yeah, you could go ahead and produce a flat toolpath that pretty much machines the whole model if you so wish. But the flat filtering consistent through all of those different types and styles of flat toolpath. Okay. Oh dear, I need to get going, don't I? All right, next one. Minimum axial engagement. Now, again, I mentioned this is more for your vortex style toolpaths. Again, we'll just quickly go through this one, but anyone that's doing any kind of vortex style, now there's a couple of different options in PowerMill. There's a from model, there's from stock, but the sum of all those parts means, that we're doing deep depth of cut, which is then going to leave the steps, but then we have the addition of this step cutting, value. Now, what that's going to do, obviously, with the deep depths of cut, the tool's then going to go back and really tidy up, though, you know, the stair effect in a way. But what you could get a lot of the time was it would really be picking up on like small fragment toolpaths. Now, with this, with the addition of this minimum axial engagement, you know, we want the step cut to be 3 millimeters, but before it could be anything pretty much up to that 3 millimeters. So having that axial engagement, or the minimum, pretty much says if I set that to 3, remove any of those areas, you know, deemed to be not required, right? And so a lot of those smaller whisper cuts or the small depths of cut could be detrimental to the tool. So reducing tool life plus increasing your time to machine. So that's a very good addition to any toolpath that where you're using that step kind of style, and that can be, it can be the adaptive vortex style toolpaths, or it can be in your normal roughing toolpath where people use it to aid their roughing and remachining. Now, I was going to show some other examples, but due to time, I'm going to quickly, well, I'm going to push forward a bit so we can get everything in. Now, there's only a couple more here, but if I have time, I can go back. But rest finishing. Now, that overlap is very important for pure blend kind of options here. Like, so, I mean, I've got a part there that's pure 3D. And then generally we would have some kind of steep toolpath, such as a constant Z toolpath, or that would be, or even a steep and shallow, for example. Now that would be a combination of a steep style toolpath and a shallow style toolpath, which could be a choice between a raster style, a lace cutting style, or a 3D offset. But you would always have to go back in and machine those fillets or the small internal corners. Now, without that overlap, you could then have, we could sometimes have, where those toolpaths blend, we could be leaving stock there. Not much, but that not much could mean an hour or two for someone hand finishing afterwards. So we don't really want that, do we? We want it to come off the machine right first time. And so if I was just to quickly zoom into that area, now I'll just turn the toolpath. Actually, I'll leave that on for now. So we've got a normal rest style toolpath. Now this is what we've got at the moment is really a combination of stitch, like more horizontal passes for the steep areas, and shallow passes for obviously the shallow regions. Now, in that rest area, what we're doing here, we can either, well, we're using basically a previous tool, and this is really encompassing all of the best bits of the previous corner finishing toolpaths. That could be multi-pencil, it could be pencil, or even corner finishing. Some were better at certain scenarios than others. So the whole reason this toolpath was brought out was, to really try and unify all of those different scenarios basically, and get it all into one good toolpath there. And we've had this expand area by. Now that was, I would say that's more of a guesstimation in a way. I mean that sounds vastly inaccurate, doesn't it? But it would over machine. Now, what we're trying to do now by getting it to overlap is over machine, but by using that expand area by, it was, again, it was a bit inconsistent, and it would lead to more toolpath than was required. So this overlap now if I quickly highlight between the two, actually mine's got expand area by here, isn't it? I think that's actually my, let's just go and quickly check that. I might have forgot to rename that one, but yes, it is overlap, but I've got it there as expand area by, but it's now a far more accurate calculation, giving us exactly what we need. So we obviously want it to over machine or overlap by anything more than 0, or a couple of cuts, for example, and that's going to make sure that we don't have that nasty blend there. So again, something small, but something that's going to really improve you know, your surface finish is not going to leave that stock and not going to lead to any additional time finishing afterwards. So all of these sort of enhancements are aiding in automation, aren't they? So the less we have to touch these style of or touch the, you know, or do any sort of hand editing, you know, that means we're freed up to do other work. And then I think the last thing I will show is the addition of the point spacing parameter to setups. Now, I never used to use these in the past, but the benefits, I mean, looking into it, I used to do everything quite manually in a way, but I would pride myself on, you know, not having to make, you know, not making mistakes or having to change things after the fact. But you come up against scenarios sometimes where you've got multiple toolpaths, and obviously I'd have them organized into folders, but setups is a much cleaner, more efficient way of grouping your toolpaths together. And again, just for time constraints here, I'm just going to show you an edit, but if I go actually into that setup, right, we can globally define, and by global I mean that, you know, I'm just going to define it once, and every toolpath from then on is going to follow the rules that I set within that setup. And again, you can take them out of that setup. You can add toolpaths, additional toolpaths into that setup, and you're not fixed by what's in that setup. You can override, but it never used to have the point spacing scenario there. So it would be one more thing that we'd have to change. But you know, I can set these rules ahead of time for a particular setup, call it top, and every toolpath follows those rules. Then I can create another setup, and then, you know, we can have all of the things like machine simulation, your important things that used to jump around all the time. We found ourselves having to manually modify them afterwards. Things like your simulation work plane or your output work plane, things like that. But now we've got the point spacing, which is good, and then we could potentially go ahead and, you know, a scenario afterwards. I can go in and edit the setup connection, split screen. Now I'll bring that across, so I can make global changes rapidly to everything within that setup. Now, again, there were ways of doing it before. You know, I hit apply there, and you can, that's what you see at the bottom there, is it's updating all of my toolpaths. But there were ways of doing it before, but they weren't really as easy and efficient as this. So you know, those additions are going to make the programmer's life, yeah, you're going to become much more efficient, and the name of the game is doing you know, least handwork as possible. Okay, just enough time for a couple of questions, I think. So I'm going to switch back. Where are we? Let's go there. Quickly, yeah, so how to learn more. Yes, I think you probably know by now that there's a big big online presence on YouTube and various other websites where, you know, if you do need some quick and helpful learning, I mean, I look at these myself, just to get other perspectives, things like that. But yes, you can go on YouTube. There's some information there, and I'm sure that KETIV could give you this afterwards. But when can you get it? Now, obviously, it says the release was the 10th of May, so technically you can get it now via your Autodesk app. But again, you can ask your partner to help out, help you get that software if you haven't already. I'll flick through this, running out of time. But again, the usual sort of, you go into your Autodesk account, pick the software you need to download, and off you go. And I'll just finish there and switch over to Joe.
Excellent. Thanks, thanks, Ted. Very informative. Enjoyed the conversation. We got a few questions that I'd like you to answer. I think we have 3 questions. The first one was 2 technical ones about there was an expand question about area by an overlap.
Sounds like the rest finishing.
Yes, rest
It's a good one.
finishing.
Good question, actually, because it is quite confusing. That's something I talked about. You've got the expand area by, and now you've got the overlap. Expand area by would really expand the area of the toolpath, but it wasn't, the way it calculated it was like, it would just calculated it along, the number would be calculated along the surface. So it was really your, you know, it was a very sort of not fluffy, but it was over defined, and it would be a bit fiddly, and it would be a bit more guesswork, let's say. So what they've done to improve that, and that will probably, that setting will probably disappear anyway, but now you've got the overlap. So the overlap is the true calculation, the true overlap calculation from the rest finishing toolpath. So that's the one you would want to be using. Hope that explains it.
Excellent. And then the other one is they want some further explanation. I think it's on the incline flat.
Right. Don't know what in particular about the inclined flat, but I can look at it talk about it from my perspective. You've got multiple, before that toolpath came out, you had multiple versions of flats. You had raster flat finishing, offset flat finishing, which used to sort of, they only used to allow you to have a cut and then a final cut. Plus they weren't 3+2 5-axis capable. I used to then sort of modify and manipulate my own one by using slice area clearance, which would then give me the ability to have multiple cuts, which is what I want. But now that inclined flats, that's probably the one that what I do use moving forward. I mean, I probably won't touch the other ones, because you can do the 5-axis toolpaths. You know, you can pretty much machine your whole job. You can do multiple cuts, and you've also got the benefit of choosing the different styles of toolpaths. So instead of just picking raster flat finishing, I can use offset or raster or model offset. So from my perspective, that would be the one to use. Yeah, much more functionality and flexibility.
Excellent, excellent. And we got another question that was emailed into us, and let me read it because it's a little bit longer. And they say that they get initial release step files from engineering, so a step file from their CAD design. However, these initial release files eventually get revised. Those revisions may or may not affect my NC code. How can I streamline the process of receiving the updates and receiving NC code accordingly? And so this brings up and I'll answer this one, Ted, very quickly. Okay. But this brings up a great question of how is the manufacturing floor and the design community and within their companies actually collaborating? How are they talking back and forth? Many times companies simply take files and dump them into a share folder, and the manufacturing team goes ahead and starts to apply toolpaths on those particular parts. And many times there's revisions that are being done, and these parts are out of date, and we spend a lot of time working on out of date data.
Yeah.
And so Autodesk has a product, for those who don't know, it's called Vault. And Vault manages all of the CAD data and many other types of data for people for check-in, check-out, latest release information. There's a whole set of features and benefits for Vault. However, we have created here at KETIV a connector called Vault for Make. And this really enables our customers to drastically reduce the wasted time of this rework, where you're working on out-of-date CAD revisions. And the Vault actually automatically notifies our programmers about the updates from CAD. So you're getting real-time updates from the CAD department or the design department, and that the manufacturing division or department is working on the latest and most accurate product that needs to be done. So that revision control of PowerMill and FeatureCam really ensures that they're working on the latest release, and it manages all those tool paths and NC codes for the shop floor. Okay. And then the other question they had was, how do I manage multiple iterations of NC code for different machines, i.e. machining the same part, but on different machines? And Vault for Make allows NC files to be delivered to the machine controllers directly from Vault. So these are highly beneficial and tools that help you have data management, better collaboration with your organizations, integration directly into those machine controls, security, that things, you're not losing that intellectual property, and of course, streamlining the workflows. And if you look at specifically Vault for Make, I think I have like 6 benefits here: synchronized design and manufacturing data, managing the bill of materials, facilitating work instruction documents, enabling change management, revision control, promotes collaboration and communication, and establishes traceability and compliance. So a well-rounded, full breadth of data management tools for the manufacturers and the manufacturing floor. So those are all incredibly powerful, all managed with a product from Autodesk called Vault, if you're unaware. And if you do have Vault on the manufacturer or on the design side, it's something you may want to look at implementing into your manufacturing. So that answers that particular question. Do we see anything else? Okay, I believe they have posted the Vault for Make site on our KETIV webinar chat. Also, for all of the other KVs that we've done, you can go back and take a look at those on YouTube, and you can simply go to ketiv.com/KVA and you will find anything you need there. So to finish up, thank you, Ted. That was absolutely amazing. There was no way I was going to be able to do that. So.
Thank you, sir.
Thank you. I do have my safety glasses, but I didn't wear them today. I didn't know if you were going to be throwing some chips around.
You don't need them with my program.
Okay. It's chipless. It's chipless. I love it. All right. Anything else you want to add, Ted, before we let everybody
No, it's good. Thank you for hosting me today.
Okay. Thank you. And we'll talk to everyone next week.
See ya.
Thank you. Bye-bye.